Consumer product design has been undergoing a surge, with products getting smaller while their requirements grow. If we take a look at projectors, for example, we've seen them move from standard definition to high definition, and now even 4K. We've also seen the integration of technology like Bluetooth speakers and Wi-Fi. At the same time, the desire to miniaturize these devices continues, meaning internal components face new challenges. Today, we're going to take a look at a conceptual design for an internal bracket that stabilizes the lens on a new portable projector. A typical scenario for a bracket like this is a 3-point bending test to evaluate its feasibility and usage. SOLIDWORKS Simulation can provide us with an initial solution for the 3-point bending test, but it takes over 20 minutes, and we have design alternatives as well as multiple load cases. So this would take hours of solve time to get the results. To speed up our solve time, we need to leverage some new tools available in SIMULIA Structural Performance Engineer, or SPE, on the 3D Experience platform. We've already gotten the model into SPE using the one-click connector. Now let's take a look at what is possible. First, let's review how SPE handles contact, because this is a game changer. Gone are the days of having to manually define contact pairs. Instead of assuming that all touching faces are bonded, SPE makes the assumption that all faces, touching or not, are no penetration, which allows them to slide, separate, or collide and develop contact pressure. Friction is automatically accounted for and can be modified. There are some automated approaches to change the bonded or other contacts, but this really is the most realistic setup. I don't have to assume which faces may or may not come into contact during the run. It's all handled for us. And SPE uses Abacus, arguably the most robust and accurate FEA solver on the planet. As in reality and for simulations like this, there's never a purely linear solution, so the solver itself is always going to be non-linear. I'll make some changes to the settings to ensure we get adequate result resolution, and as we move to the materials interface, we can see that SPE offers us a wide range of material models. From linear elastic to advanced hyperelastic, temperature dependent, and credit models, SPE is going to offer the appropriate material physics for your analysis. For the support beams, let's delete the mesh that came over from SOLIDWORKS and move to a nice, structured swept brick mesh. This meshing scheme will help speed up solve times while ensuring a high accuracy result. Now we're ready to run this problem. And because it's a relatively small model, I'm going to run it locally on my machine. The solver is very fast, so within 5 minutes, I have results for the full run. But for larger problems, I could take advantage of cloud computing. Cloud computing can exponentially reduce solve times while freeing up your local machine. Now, if we take a look at the results, we can see the model going through a full range of motion, and we can highlight where plastic deformation has occurred. While the requirement was for 20 millimeters of deformation, we expected a worst case scenario, a deflection of 80 millimeters. And within 10 minutes, we were able to get results in SPE. Because of high strain localized buckling and complex contact, this worst case scenario was beyond the scope of what could be solved in SOLIDWORKS Simulation. The beauty of working between SOLIDWORKS and SPE on the 3D Experience platform is now when we make changes in SOLIDWORKS, they can be immediately reflected in SPE, and we can reevaluate our designs quickly without redundant steps. With a 5-minute runtime, I now feel confident that I can evaluate multiple designs and load cases fast. With SPE, we are able to leverage an existing SOLIDWORKS simulation setup and use the powerful Abacus solver to get through tough FEA problems, whether it's reducing run times or solving problems that were previously outside the scope of SOLIDWORKS. SPE provides a robust solution and is the first pathway for existing SOLIDWORKS simulation users to use the next generation of simulation tools.